All right, check it out. Lesson 8.5, adding and subtracting rational expressions. I think I'm going to take you back to like maybe grade 3 or 4 here and just do a quick example of adding, well, subtracting just a regular fraction, and just so we can see the similarities between what we're going to do today and what you've done in the past. So if I had 4 over 8 minus 2 over 8, nobody sitting on their couch or behind their desk at home is going to have trouble saying, okay, so I've got a common denominator set up here already. That's going to be good for my new fraction. And then I'm just going to simply do the operation with the numerators on top. So I'm going to get 2 over 8. Okay, so that's the actual adding or subtracting part. The part that might get a little tough down the road with the rational expressions, when we put some binomials and stuff in there, is the actual simplified part. So here, that's the addition subtraction, but we'd want to leave it as a simplified fraction, so we see 2 on the top and 2 on the bottom, and we can reduce it to 4. So there's kind of one step where it's the actual operation that we take care of, and then the second step is to simplify it. Okay, so let's follow those concepts through with what's going down on in our examples here. So for example, in this one, again, our denominators are the same, so I can put it under one fraction. I do the operation up top to get me the 12n over 15, and then I just simplify that 12n over 15 by dividing the top and bottom by 3, and I get the 4n over 5. Okay, in the second example here, again, the operation is just dead easy, right? I see common denominator in the bottom. I perform that operation to my two numerators up here. I combine them, okay? I do the subtraction, but now when we go to do the simplification, some of our factoring ideas and simplification ideas with binomials and things like that come into play. So I see that there's a similarity here, so I factored out a minus 1 so I could make the top look exactly like or one of the factors in the top look exactly like a factor in the bottom. So now I can cancel those two out, and really all of this turns into a big fat minus 1. Okay, let's try a couple of examples here. I'll kind of do one of the easy ones, and then I'll do one of the hard ones, and then you guys can give it a try on the other two. Okay, so which one should I do here? Okay, let's look at number 2 maybe. That's kind of a medium of the road, middle of the road one. Okay, so I see that I've got a common denominator of 8. So I'm just going to go ahead and subtract the two things on top. And I guess if you wanted to, this is like as simple as it can get, but if you wanted to write it in factored form, you could factor an x out on the top and get one of these. But there's not really much simplification to be done there because I don't have any common factors in the numerator and the denominator, right? And number 4, I think, is one that's probably going to show a common mistake that students sometimes make. Let's go through it here. So again, first thing I'm going to do, make that common denominator. Okay, use the same denominator in each for the common denominator, my fraction. And now I'm just going to go ahead and do the operation. But this is going to give me the wrong answer, okay? So what you have to remember is that these divided signs have an implied parentheses around them. And we all know that when I go to do my order of operations, I've got to do the parentheses before I do anything else. So when you do the subtraction especially, it's really important that you put this set of parentheses around here because that negative is going to distribute to both of those pieces. Okay, so really, well, let's go ahead and do the subtraction there. I'm going to run out of space here. I'll just move it up in a second. So m plus 1 minus 3m, and now I do the distribution, plus 3 all over 2m minus 1. And now I'm going to collect my like terms in the numerator. So it looks like I've got 1m here minus 3m gives me minus 2m's. And I've got plus 1 here plus 3 there gives me plus 4 all over 2m minus 1. And I guess if we want, we can simplify that a little bit more by factoring a common factor of minus 2 out of the top here. Minus 2 all over 2m minus 1. So take a look. The actual, let's get my little arrow here. The actual subtraction part is dead easy. Like that step pretty much ends here. Okay, as long as we remember to distribute that minus sign, we're okay. But what we're going to find the challenge to be moving forward is to actually simplify it so we see it in factored form. So if we do have common factors in the top and the bottom, we can cancel them. I'm going to give you guys a crack at, why don't you guys go ahead and try the other exercises on this page. Oh, why don't we do one more, just for funsies? Yeah, let's do number 8. And I'll let you go and try and do a couple more. Okay, so number 8 here. I see my denominator is common. Awesome. So let's put that in the numerator. Okay, I'm going to go ahead and do the operation. Make sure I consider these parentheses here with that minus sign. Distribute out that minus sign. Collect like terms. So here a minus a is nothing. All right. So and 4 minus 6 gives me minus 10. And away you go. Okay. Yeah, go ahead. Let's give those other ones. Why don't you guys give 3, 6, 5, and 7 a try there. And I'm just going to push pause, and I'll click the answers back up, and we can take a look at them. So hopefully, as you work through those examples, you saw the same kind of the same 3 steps kind of emerge, right? Put the fraction together, perform the operation, and then simplify if you could, whether that's was just factoring and canceling or just plain factoring. Okay, here same thing, same denominator, perform the operation, factor, and here we had one where the same factor appeared on the top and the bottom, so we could cancel it out and you get an answer of 2. All right, which other one do we want to look at here? 7 is a good one. Okay, so that doesn't always happen, right? Look at number 7, same thing, same denominator, perform the operation. I factored, but here it's not the same, right? X minus 2 isn't the same as x plus 2, so we just leave it as it sits in factored form. All right, let's move on to examples where the denominators are not the same. We've just kind of added one step to this, and that's to find the LCD of the expressions. Okay, so that we can find that common denominator. All right. So for example, our denominators here are unlike. So I want to go ahead and try and find a way to rewrite this equation so that I do have the same denominators with each of these. So the idea is that you're going to use an equivalent of 1 to multiply to one or both of these expressions that I'm trying to add so that the denominator ends up to be the same. So in this case, for this first expression, if I multiplied 4 on the bottom, I would have the same denominator. So that's kind of what I'm going for. But if I multiply by 4 on the bottom, that means I also have to multiply by 4 on the top to keep my equation equal. I'm just multiplying by a 1, but I'm writing it as a 4 over 4 so I can match the denominators. So here, that's exactly what they did. They multiplied top and the bottom by 4, and then the steps were the same as in the previous examples. Denominators the same, perform the operation on top, and simplify. Okay. Let's look at example 2 here real quick, because it's one where they've got binomials, and that concept is the same, still applies, right? So I don't really see my two denominators are not alike here, so I want to multiply something in the bottom so that I can match the denominators. Okay, so I factored out the bottom here to kind of see what I was going to need there. I'm going to find that my LCD between these two things is going to be the x times x minus 4. So in order for me to get that least common denominator in the bottom, sorry, I should have said least common denominator in the bottom, okay, I'm going to multiply this expression by x on the top and the bottom. So now my denominators are matched. Do the same to the top here to keep this fraction equal to what it started with, just multiplying by a weird looking 1. And then I'm going to go ahead, same denominators to 1, perform the operation, and simplify. Okay, here the x was common to the top and the bottom, so I could cancel it out. All right, so it's really the it's this idea of LCD, and the simplification is what the goal is. It's actually not the addition or subtraction that's a super issue here. Okay, so let's look at number 2. So first thing I want to do is find that LCD between the two. So I want to match my two denominators, right? So if I write 6x as 2 times 3a and make it in its prime factors, and I write 8 as 2 times 2 times 2, if I take the biggest, well here, I'm not going to write that 3x quite like that because I want to see that as a factor as well. Okay, so I want to take the biggest group in each of them, and that'll give me my LCD. So my LCD here, so I look at my 2's, so my 6x was here, my 8 was here, so my biggest group of 2's is 3 2's, right? So that's 8. I see my biggest group of 3's for both of these is 3, just one of them, and my biggest group of x's is x. Okay, so that's going to give me my LCD of 24x. All right, so what I want to do now is rewrite both of my fractions so they have that least common denominator. Okay, so what did I have to add or multiply by 6x to get 24x? I had to multiply by 4. If I had to do it on the bottom, I have to do it on the top to keep the equations equal. So this expression here turned into 4 over 24x. Okay, or I'm rewriting as 4 over 24x. Over here, what did I have to multiply the 8 by to get 24x? I had to multiply by a 3x. So if I multiplied that by the bottom, I have to do it on the top as well. So over here, I'm going to get 9x. All right, so that's the tough part. Now we just do what we did in the exercises previously. Write it as one fraction. Perform the operation. And if there's some factoring or something to do in the end, you can rewrite it and cancel. Here, nothing to do. This is a big fat no-no. Okay, a lot of you are going to see this answer and you're going to, oh, I have to simplify something, and you're going to hear, I'm just going to write it over here. Okay, and you're going to get excited because you know you did everything, it feels all right, and you're going to want to cancel these x's out. No, you have to remember, oops, here, bad. Don't do that. Okay, what you have to remember is that our PEMDAS has all of this kind of as an expression on the top. So unless you can factor something to the outside, you can't cancel it with the denominator. It has to be multiplied out. So my first expression I'm going to rewrite. Looks like I can factor that with a difference of squares. So this is going to be q plus 4 times q minus 4. Oh, the factoring makes it so much fun. And the second one, plus q plus 1 over, what number is multiplied to 4, add to 5, when 1's my coefficient. Let's give that one a q plus 1 and 4, I think. Sounds like a good one. There we go. And so look, this is kind of where it can either turn, you can do yourself a favor and make it easy, or you can do it the hard way. After you factor things out, go and simplify each expression so it's in simplest form. All right, so we want to cancel out this q plus 1. If you try and add those two things together without simplifying that first, it turns into a bit of a nightmare. So I'm just going to rewrite that real quick. So q over, this one stayed the same, q plus 4, q minus 4, plus 1 over q plus 4. Okay, and now looks like my LCD, I'll just write it over here somewhere, is going to be biggest group of q plus 4s is 1, and the biggest group of q minus 4s is 1. So I want this to be my LCD, so I really just need to switch up my second fraction here by multiplying the top and the bottom by q minus 4. Okay, now we're ready to rock. Okay, so all of these are equal. Q plus 4, q minus 4 on the bottom. Okay, and add what's going on. All right, let's see how you did. Look at number 1 there. It's a simple case of, here I'm just going to do the pointer, matching denominators. So 3a, I need to make this one a 3a, and do the same to the top as I did to the bottom. So 10 over 3a, so it's so small there. And number 3, just remember how to find an LCD. Yeah, in this one it was pretty straightforward, but I know that a lot of people are just going to want to start multiplying those numbers together. That'll give you a common denominator, but it won't give you the lowest common denominator. So if you use the lowest common denominator, it saves you a bunch of work at the end to simplify. So so I just multiplied this side both by 3 on the top and the bottom, and this side 4a on the top and the bottom. Matched the denominators. Same did the operation on top, and then did a little bit of factoring here. So 24 divided by 12 gives me 2. I can simplify, and away you go. Okay. In number 4, same thing, right? So match the denominators. Okay. Did the same on the top as I did to the bottom. But in this case, common mistake I've got outlined in red here. When it's a subtraction, you just have to remember that when you distribute out, okay, make sure that that negative goes to both terms in that second part. Whoa, I gotta finish off here. Let's just do a quick fill in here. 4h minus 2h gives me 2h. 8 minus 2 gives me plus 6 on the top, all over h plus 2 times h plus 1. And then I'm just going to factor the top into 2 times h plus 3 over h plus 2 times h plus 1. Looks like a good one. Okay, next one we want to take a look at here is number 5. So I'm starting to shorten the steps up here a little bit. So find your LCD. So just so you don't have to write everything over and over and over again. But write your LCD, matched, sorry, let's get the pointer, match the denominators. Okay, made sure I distributed out on the top for both of these, collected terms, and wrote the final answer. Okay, but just make sure here that you don't do factoring that's magical. This can't be factored. A squared plus 16 can't be factored, so there's nothing to cancel there. All right, let's take a look, last but not least, at number oh, I guess we can take a look at 6 here quick. Okay, exactly the same. Okay, LCD, match denominators, nice here. Same one denominator in the bottom, and then just be careful to collect the like terms. Factor out the top. Nothing cancels, so we leave it sit like that. And last but not least, and this one was kind of a tricky one actually, number 7. Okay, there's a good lesson to be kind of shown here. So same thing. I need to factor it first, just like in number 8 there. But make sure that you simplify before you go to do the common denominators. And this one you didn't even have to. Okay, so up here, once I factored, I saw y plus 2 was common, so I canceled them out. And in this one, when I factored the bottom, I saw y minus 2 as one of the factors, and it's not quite the same in the top, so I factored out a minus 1. To make those two look the same so I could cancel them, and you didn't even have to match the denominators here. They were already the same, right? Okay. One thing you just want to take a look at is that these two minuses here are going to make one big fat plus there. So you ended up with 2 over y plus 3. That should do it, kids. Another video there. Hope you got something out of that. I'll try and do better next time.